Well, hello, friends in Algebra Land. This is Mama Cos, and I'm coming to you live from the dining room. And today we're going to look at some exponential function notes. In fact, it's our second day on exponential functions. And today I have a PowerPoint slide to go along with the notes that we've done in our pink book. So you will see this PowerPoint on Google Classroom. And as we work through it, if you will use the editing view instead of present view, if you will do, I will share it to you this way. And then you will notice that there are text boxes on all of the blanks for you to be able to interact. Okay, so you pull yours up and you can watch the video at the same time or press pause and see how that works for you. All right, so we're going to go ahead and get started. These are the notes for today, and for today we're going to think about our notes from Monday when we first looked at exponential functions. So you help me think about some characteristics of an exponential function. One of the things that we said is that exponential functions have, so we will just say exponential functions have something special about their exponent. Do you remember what it is? They have x, or the variable, in the exponent spot. The second thing that we said about exponential functions is that they have a constant ratio. That is, you are multiplying by the same value down the y column. And we compared that to linear functions. Remember, we said in linear functions, we have a constant rate of change. That is, we are adding or subtracting the same number down the y column. But in exponential functions, the y values change by multiplying. So we'll say y values change by multiplying by the same number. And that is called a constant ratio. And we said you could find that by dividing the second number by the first, the third number by the second. So second y by the first y. And that would need to equal the next one. So the third by the second, or the fourth by the third. Third y value by the second y. Okay. We also, a third thing that we said is that exponential functions have a J-shaped curve. Not straight, like a line, not the U shape like a quadratic, but a J shape. Okay? Two things that we talked about a few days ago. In today's lesson, this is our objective, that we're going to be able to determine if something is growth or decay. So we're going to be able to determine if it's exponential growth or decay. Decay. Ooh, that didn't look very pretty. Let me fix that. D-E-C-A-Y. Decay. Or and the second thing is that we're going to be able to explain. I will try to be neater with this, sorry. Explain and use the parts of an exponential function. Alrighty, so that is a review from Monday's lesson and an explanation of what we're going to be doing in today's lesson. Okay? All right, so if you need to press pause here and get that written down, go ahead. If you're good, then we'll keep going. So here we are. Now we're going to see the note, and it says, any quantity that grows or decays by a fixed percent, and that's what we said, a constant ratio, at regular intervals is said to have exponential growth or exponential decay. And so I'm going to scroll down. Now I've given you some instructions on your Google Slides about how you can graph this. If you just want to graph it on your calculator and look at it, that's fine too. If it seems a little awkward, we'll have access to our calculator. Y equals 1 times 2 to the x. So the first thing I'm going to do is move this out of the way. You should now be on this slide. All right. I'm going to come over to my Desmos calculator. Maybe. There it is. And I'm going to type in y equals 1 times 2 to the x power. And remember, there's your power key and x. And so I'm going to, oh my goodness, I'm zoomed out super far. So I'm going to zoom in and drag. That's the nice thing. Remember, with Desmos, you can just click and drag. And I still need to zoom in some, and I still need to zoom in. Well, there we go. Okay. If I'm going to graph this on my graph, I can see what it does, but to get exact values, remember we can change this into a table. So let's come over here, edit list, and then convert to a table. And looky there, isn't that amazing? So if you can pull off some of those values, that's super. Let's see, I have 1, 2, 4. Before that is half. Before that is a quarter. And sure enough, it does look like, if you'll notice, it certainly does look like what? From here to here is times 2, times 2, times 2, times 2. And that is my base right there. So I'm going to pull these values right over here on this graph. Okay. And I can come right to my graph and very carefully, let's see, when x is negative 2, I'm just barely up at all, a quarter. And then when x is negative 1, it's a half. And then when x is 0, it's 1. When x is 1, it's 2. When x is 2, it's 4. And I bet you could predict the next one if we're doubling all the way down, double 4, and you get 8. Double 8, and you get 16. Double 16, and oh my goodness, we're off the chart. Probably up about there, 32, something like that. Right, so now we're going to take, and I'm not doing a very, oh my stars, that was not what I wanted to do. Okie doke, let's see. Something like that. And then it increases at a growing rate. It's still widening, but it's harder to see. And this looks like this is flattening out this way and approaching 0. Never really gets there. Let me erase that. That's messy. Okay. Uh-oh. What the heck just happened? I erased all my stuff. I think I turned off my Mobi viewer. Where'd he go? There he is. Let's try that again. It was there. 8. 4 was 16. So that means 2 is 4, 1 is 2, something like that. Okay. And I'm sure yours looks much better than mine, but there it is. 1 times 2 to the x, and that's what the graph looks like. You can do the same thing with the second one, y equals 2 times 3 to the x. You can go back to the calculator and type in 2 times 3 to the x power. You can go to table and get your wonderful values. And we get values that look like this. When x is 0, y is 2. Let's see. We can do this. All right. I'm not sure why there's two. I'm not sure why there are 2 of them on here. When x is 0, y is 2, which would be like right there. I'll just have to just draw right over my face here. When x is 1, y is 6, which is right there. When x is 2, y is 18, which is right here. When x is -1, we are at 2/3. And when x, all right, something like that. So it's going to look like this. And that is an extremely rough sketch, but there it is, not bendy like that. Of course, in a perfect world, it is a smooth curve and not jiggity-jaggedy like mine. So I'm sorry. So there are our 2 first graphs. Our next question at the bottom says, what do you notice about both graphs? So let's think about that. What do we notice? What's the same? What's the same about both graphs? Well, they're both in quadrants 1 and 2. Both of them point to the left and point up. So what do you think? Are these growing or are these decaying? That's right. Both of these are growth. So I will, if you need to press pause here, go ahead. Otherwise, I'm going to scroll down to the bottom. And what do we notice about both graphs? And we notice that both graphs are growing. Okay, they both look like that. The y values are getting bigger and bigger and bigger. They seem to start at 0, and then they just grow and grow and grow. Alrighty? So that is example 1 and 2. I hope that worked for you.